Hello everyone. So today we are going to solve the problems of the day for GFG. Okay. So in these questions we have an array. Okay. Uh, and we have the value of the sub array is defined in the bitwise join of all element in that sub array. Your task is to compute the bitwise join of value. That means we have suppose an array 1, 2, 3. We have to calculate. We have to find the join of every sub array. Okay, and then we have to find the join of all that value. Like suppose 1, 2, 3 is there. So what are the sub array? So first this is like suppose 1. Okay, the join of 1 is 1. Then we have, if we start with here 1, 2, so join of 1, 2 is 3. Then we have 1, 2, 3. So join of 1, 2, 3 is 0. Okay, so then we have 2. The join of 2 is 2. Then join of 2, 3 is there. Okay, and then 3 is there. Now we get the join of all that subarray. Now we need to join all this, and whatever the things is, that is our result. Okay, we will try to understand while coding. Okay, so whatever the issue we get, we will think on that. So first, if we try the brute force approach, which is not going to pass, but we'll say like what should at least come in our mind. Okay, so int n equal to array dot size. Okay, uh, we are going to the loop int I equal to 0, I less than n, I plus plus, another loop for int j equal to 0, j less than n, and j plus plus. Okay, this one loop. Now what I was saying, like we are going to find the job of first 1, then 1, 2, then 1, 2, 3. Okay, so we need a currently job which is going to give you the job of each subarray. So here we are defining int cur job, okay, which is 0 now, and we are going to cur job of is are equal to array of j. Okay, and okay, this will start from I, like I just said, from 1, then this one, then this one, then when we are on 2, then 2, then 2, 3. So this will be okay. Now what is suppose in our result? Okay, what the result is, like with everything, because what the result is actually the job of each one. So what we are doing result equal to result job, and this cur job. Okay, and simply we are going to return. Okay, so we are trying to run. Okay, if we submit, it is going to give the TLA. Okay, okay, so if we see what is the complexity, then this one is for n, and this one n, so n square. Okay, so this is going to for the n square. Okay, now if we try to optimize, okay, so we finally we need to do the XOR. Okay, okay, so what we can do, we want to know like whatever the element is there, suppose this 3 is there. Okay, this 3 is contributing in how much subarray? But like if we see manually, this 3 is contributing in a subarray which is already 3, or either 1 2, or 1 2 3, or 2 3, correct? So if we are able to contribute, find that if whether element is going to contribute in how much subarray, then we can do things like, suppose if this element is going to contribute in 4 times, that means if event time or number come, then that the joy become 0, and if odd time is there, just we are going to add this joy in our result. Okay, so our main target is to find that in how much subarray this 2 is going to contribute. Okay, so to build this, I am going to explain like, okay, so what are the possible, if we take 2. Okay, so if we take any subarray, that means I have like a small page for you to show like how can we think. Okay, like this one. So what is a subarray? Subarray means that it should have an element, so it will go from left to right. Okay, now and in our condition is there like I should be there. Okay, this is compulsory that I must be there. So from I we can go some left or no left, and similarly some right or no left. What are the different things are there? So I is there, we can go some left or not left, that's why it's like equal to, and similarly right. Okay, now what the L has, what the L can be, that means where it can start from. So if we start from, okay, if we have to find 2, and if we start from 3, then we can't get, because we are then we do not get this 2. Okay, so we have to start at least here. Okay, and whatever, if we want to go back anyway, we can go any two back. So that is the things. So we have from 0 to I we can go. So for L we have I plus 1 choices. Similarly for right, okay, so similarly for right also we can pick I, and we can go and take anything up to n minus 1. Now one thing should be in the mind, why we'll take I again. It might be that some things is going to do, like what we can say, like some things is going to get repeat. No, the thing is, okay, so now, okay, so like in the case of left we see like there is a from 0 to I. Now from R we said like there is from I to n minus 1. Now suppose let us the thing like this is an array, this 2, okay, and this element is this, and sub array is also 2. So what is its left? It's left with the same element. If it's and its right is same element. If your right is I, if you write your right, okay, from the next element like from here, then you will miss this also. Okay, so this is the things, that's why we take this one. So how many choices is there? So this is choices is the n minus 1. Okay, now so we have left choices this one, right choice this one. If we multiply them, that is going to give us the total choices, which is this one, just I plus 1 into n minus 1. Okay, now so like this is our loop. Now we want to know like what are the choices we have. Okay, so then we okay, stop int choice, that means choice means subarray. So int choice equal to, no, what our math formula was, I plus 1 into, but this one is n minus I. Okay, n minus I, and we know that this I is big, 10 to the power 5 into some such number will create issue, so we will make it long. Okay, and this I also we will typecast. Okay, now we have choice. Now this is going to come. Now if we check like if this choice is in event time, that means we are finding the jar in the event time, so that is going to contribute 0. That is of no use. So if we check, if choice modulus 2 equal to 0, right? Okay, if choice modulus 2 equal to 0, that means it is not going to contribute. And if it is 1, then it is going to contribute. And how it is going to contribute? So just single time, because if it is odd also, so whatever the things that come in even number, that got cancelled and just one left. So result equal to result jar array of I. Okay, and finally we are going to return. Okay, let's run this. Okay, if we submit, okay, okay. Now if we talk about its complexity, so uh, we are just moving to the one loop, that is big O, that is big O of n. Okay, okay. Thank you for watching.